Alright, this problem says a compound is analyzed to have 83.62% carbon and 16.38% hydrogen. The molar mass is 110 grams per mole. Find the empirical and molecular formula. So we have two things to do here. The empirical formula is going to come first, and I have mentioned before the use of this rhyme helps to remember the steps that we do to find empirical formula. So let's do that first. Alright, percent to grams. Well, that's the easiest part of the conversion because I'm always going to assume that I have a 100-gram sample. And that just means that it's going to be easier to work with when I'm dealing with percentages, because if I have 100 grams, then the percentage matches the gram value. I could do 150 grams, but then I would have to figure out what 83.62% of 150 grams is. So it makes it easier to deal with the math if you just assume that you have a 100-gram sample. So if I have 83.62% carbon, then I have 83.62 grams of carbon. And if I have 16.38% hydrogen, I have 16.38 grams of hydrogen. So we've taken care of our percent to grams step. Now I want to convert my grams to moles. Well, if you have been following along in class, you know that we need the molar mass anytime we're converting grams and moles. And where do I always get the molar mass? Well, I get it from the periodic table. So I'm going to go to the periodic table and I'm going to look up the molar mass of each element. So I look up carbon, and 1 mole of carbon has a molar mass of 12.01 grams. And 1 mole of hydrogen has a mass of 1.01 grams. And I'm going to use these conversions in my conversion factors. So let's do that. How many moles of carbon are in 83.62 grams of carbon? Set up my bracket system, my dimensional analysis. Grams of carbon is going to go on the bottom because I want to cancel that. Moles of carbon is going to go on the top because I want to find moles. And in 1 mole of carbon, there's 12.01 grams of carbon. And I get that right off the periodic table. And what else? How many moles of hydrogen are in 16.38 grams of hydrogen? Grams of hydrogen on the bottom because I want to cancel that. Moles of hydrogen on the top because I want to find that. In 1 mole of hydrogen, look over here, I have 1.01 grams. Grams going to cancel. So I basically have 2 division problems to do here. I have to do 83.62 divided by 12.01, and I have to do 16.38 divided by 1.01. So I divide 83.62 by 12.01, and I end up with 6.963. 6.963 moles of carbon, and I end up with 16.2 moles of hydrogen. Now again, we've talked about this before. I cannot just use this as my mole ratio in my formula because I cannot write C6.963 H16.2. I'm not allowed to use decimal numbers in formulas. I have to use whole numbers. So the first thing that we do And we go back to our rhyme. Remember, we've already done grams to moles. Took care of that. Oh, that's supposed to be a check mark there. Divide by small. So which one's the smaller of the two? And again, it doesn't really matter what I do to both these numbers as long as I do the same thing to both of them. The ratio stays constant. I'm going to divide by the small. When I do that, 6.963, 6.963. Oops. Undo. 6.963. Excuse me. I get 1 here, obviously. And what do I get here? Well, I end up with 2.35. Now again, I cannot say, okay, so my answer is CH 2.35, because again, that's not a whole number. Can't do that. So what do? Well, look at our rhyme. What does our rhyme say? Well, we've already divided by small. Multiply till whole. So what I want to do is I want to start, and remember it's the simplest ratio that I want because it's the empirical formula. I want to figure out an integer, a whole number. When I multiply that whole number by 2.35, it gives me a whole number. But whatever number I multiply it by, I have to multiply both of these numbers because our ratio has to stay constant. So I start with 1. Well, obviously 1 won't work. If I multiply this by 2, I'm not going to get a whole number. So I try 3. Will 3 work? Well, it ends up working. 2.35 times 3 gives me 7. But again, whatever I did to this number, I have to do to the other number. So I have to multiply this by 3 as well. And that gives me 3. And these values, the 3 and the 7, are my subscripts for the empirical formula. So C3, H7. That's the first half of my answer. That's the empirical formula. It also asks us to find molecular formula. And the molecular formula, really what we want to do is we want to figure out what the multiple is. And that would be what Bx is. Once we know the multiple, we can distribute it in. Remember, the molecular formula is the true formula. It could be the same as the empirical, but it could be larger values for the subscripts. We don't know. So what's the formula for X? Well, the formula for X is the molar mass, which is given in this problem way up here, right, 110, divided by the empirical formula mass. Well, how do I figure out the empirical formula mass? Well, it just so happens you have the empirical formula right here. So all you have to do is figure out the mass of this using the same steps you would do if you're finding molar mass. How many carbons do I have? I have 3. What is each carbon's mass off the periodic table? 12.01. And I'm going to add that to what? I'm going to add that to 7 hydrogens times what? 1.01. Okay. So when I multiply those out, I end up with 36.03 plus 7.07, which sums up to 43.10 grams. That is the empirical formula mass. So I'm going to plug that in, like the sound effects there. I'm going to plug that in there. The molar mass was given, so that's 110. The 43.10 will go right here, 43.10. And when I divide, check that. There's a typo here, but let me fix it real fast. Sorry about this. We're going to have to change that number. This should read 86.17. Sorry about that. I looked at the wrong problem. And where else do we need to? Well, I guess nowhere else. Alright, so 86.17 is supposed to go here. Oh, gotta change this too. Sorry. Let's just go back here. So the molar mass is given, that's 86.17. This is the empirical formula mass, which we just solved for. And what do I get when I divide those? I get a 2. Well, that means that x equals 2. So if x is 2, I have to go, just follow me over here. Okay, I have to take my C3H7 and distribute my 2. So 2 times 3 is 6. 2 times 7 is 14. And my molecular formula is C6H14. So here's my empirical. After I find my empirical, I use this formula to find the multiple. The molar mass was given after we fixed it, 86.17. The empirical formula mass I had to solve for. I plugged it in there. 86 divided by 43 is practically 2. It's not exactly 2, but it's close enough. 2 is the multiple. 2 times 3 is 6. 2 times 7 is 14. There's my molecular formula.